three elements, one engine and two machines, and let's see what are the results. So this is a block diagram. Coming to this configuration, we already know what are the meanings of this configuration. So now I will go ahead with the next GUI. So this particular GUI is going to ask me for the driving cycle data and acceleration test and the gradability test. And if I want to add some electrical load as well. So let's say we are going to simulate two number of cycles for Toyota Prius. So now I'm going to run this particular model and we'll get the result files. So here we have got the result where in the second graph you can see this particular state of charge of the battery started from 70% and it decreased to this value, and it keep on decreased to 50%, and then the engine has taken over to manage this acceleration, and whenever the deceleration has started, you can see some rise in the state of the charge, and then it is again maintained to 50%. The arrangement or the control related things or the strategy of driving the vehicle is such a way that it will not go beyond 50% state of the charge. Here you can change some of the plots. For example, if I wish to change this plot, I have to click here and then select what plot I wish to get. So if I wish to plot power, which is referred to this generator component, so this is generator power. So look at this generator power, and here you can see a lot of negative values, because in this condition the power will be flowing in other direction. Now let us have a look at emission and fuel consumption. So total 24 kilometers of this two cycles, this is the first cycle and second cycle, has been covered. One cycle is approximately 12 kilometers, and you can see the emission related data here. So we can again check the energy use figure and output check plots, and you can simulate the data, or you can test the data as well. Here for a Prius case, you can see another one which is Prius speed. So this one is really interesting to understand about what happens with each component of the Prius car. So this particular plot is a driving cycle. 2 units of driving cycles are considered here, and the second plot is generator, engine and the motor speed at this particular time. So at time t equals to 0, this red vertical line is indicating what data are shown. So at time t equals to 0, this is speed, or in RPM. Here the speed is from minus 5000 to plus 6000. This is the speed for generator, this is the speed for fuel converter or engine, and this is speed for motor controller. So now if I move this particular slider, this red vertical line is going to move ahead, and we will be able to know what is happening with all the speeds. So for example, let's say now I am at this position where speed is around 41 kilometers per hour, and this is happening at 72th number of 72 second. This value of the RPM for generator is 453. The engine runs at 1200 RPM, and this is running at 1487 RPM. So this is motor controller speed. So I can move the slider, and this values will also move. So let's analyze what happens when we are considering higher speeds. So let us consider the speed which is 88 kilometers per hour, which occurs at 229 number of second. Now here, to generate 88 kilometers per hour speed, the Toyota Prius control strategy operates in such a way that the generator RPM is 2740 in negative direction. So now the generator is running in reverse direction, and accordingly the power flow is managed. The engine is running at 1500 RPM approximately, and this motor controller is 3200. So this is running in both the direction. So the Toyota Prius is such an arrangement where a typical machine which is acting as a generator attains the both type of speed, positive and negative as well. So this is interesting case with Toyota Prius. So here if I move, there may be certain higher negative values for the higher speed. So this is the case where let's say the steady state condition where the vehicle speed is 0. So in case of the vehicle speed 0, the engine runs at 1200 RPM. The motor controller is also at the rest, and this is 4320 RPM. So this is what happens with the Toyota Prius and all three component speed. So these are the interesting results. Here you can see if the vehicle is at rest for longer duration, you can see all three are at 0 RPM. So let us understand this, how it happens with the Toyota Prius, and let's open up the block diagram of Toyota Prius. So here I will be going back to 2. So here is a Toyota Prius model, and from this particular GUI I can open up the block diagram. So we are interested in knowing that how this typical generator runs in both the direction. So how the speed or how the RPM becomes negative for this case, and how power is shared between all these three components, and what happens to the vehicle speed at that time. So we have to understand this particular block really. So if you have already studied something about Toyota Prius, then you will be knowing about it. But let me show you what exactly happens in case of the Toyota power split device. So here I got one important website where I can identify this particular arrangement of gear system, or this is known as a power split device, which is nothing but a CVT. So this is a power split device arrangement, and here I will be showing you what happens with this power split device. So this is at the rest now, and neither of the vehicle is running or engine is running, so entire system is at rest. So this is the sun gear, this is a planet carrier, this is ring gear, the vehicle arrangement, and here you can see from their color about which source is considered. So the outer one is with the MG2. In this particular website, it's denoted as motor generator system. So this is motor generator 2 and motor generator 1. The sun gear is connected with the motor generator 1. Now here, if I increase the speed, let's see what is happening. So the IC engine is at rest, and the 12 miles per hour speed is obtained through MG1 and MG2 and taking the power entirely from the battery. For example, I can increase this to certain extent, and this will come to a value which is like this. So here, if you see, if I make this engine RPM 0, you can see this part is not rotating, and the moment I increase it to some value, this will start rotating. So main motor generator 2 is behind controlling the speed of the vehicle, and all other two elements are matching with each other through a line. So this happens through a typical power split device inside a Toyota Prius. So here you can see, if I increase the engine RPM, and then the engine is going to share the load, and I cannot go beyond a typical value. Here I am going to see one alarm where the maximum RPM for motor generator 1 is limited to 6500, and now this is no longer in line. So for a safer value, or for possible values, all these 3 points should be within a line. So if I go to the higher value of let's say 30 miles per hour, then I can probably turn off the engine as well. So this engine is not delivering any power now. Let's check how much maximum speed we can go only on battery. So the engine being off, I can go up to 40, 44. Okay, now here I have reached to the limit of motor generator 1, and I have to reduce this value. So this is 42 miles per hour. So Toyota Prius can go up to 42 miles per hour with engine in the off condition, only in the battery, only taking the power from battery. So this is the case. Now if I keep this above, then I can probably increase the speed to certain level. So let's say this is now around 50 miles per hour. So this is 50 miles per hour where MG1 is in negative direction, 81 RPM. You can verify the similar thing with this particular arrangement as well. So for example, if you have a condition near to this, where the speed is 53 kilometers per hour, right? The same can be arranged in this particular configuration as well. So here the speed is, let's say, 53 kilometers per hour at 459 seconds, and these are the speeds of the different components. So this can be let's say what is the engine RPM here, 2152. So if I make the engine RPM with this is a fuel converter or engine to 857, then probably I will get some other value for MG1. So if I keep it to 2800, so this is nearly 2800, and this MG1 is now running at 23,000 RPM. So this is how can be done. This particular speed corresponds to the generator part, and this will give us the idea about how we can run it, or how it is expected to run at a typical speed. So here I can move this here and check for a typical condition where what is the motor speed and RPM. This is about Toyota Prius and its internal arrangement. Now coming back to the modeling of this particular power split device. This power split device is basically where this particular speed is now negative, the vehicle moving backward, and this reverse gear can also be power can be shared like between MG1 ICE and MG2. So let me keep all the values to 0 now. And now let us understand how this particular gear system works. So this gear system model I'm now going to open up, and let's say so you have seen a similar arrangement over there. If I open up, so this point number 1 is torque and speed required from the fuel converter, or let's say engine. This is point number 2, point number 3, and this is a final point 4, where this is a final drive, to the final drive, or this will go to the wheel or driving axle. So here you can see there is a combination of all the things. This is how the planetary gear set is implemented in a model. Here you can see the inputs and the outputs, and they are summed up together, and you can see this number 4 is coming up with the addition from all these levels, starting from number 1, 2 and 3. So this is engine, motor generator 1, motor generator 2 related parts. So this is a planetary gear implementation in a model. So this is about the Toyota Prius. Now we can see that this particular model, or this arrangement, can also be changed to a pure electric vehicle. So let's take a case of pure electric vehicle, General Motors EV1.